Hello, everybody, and welcome to week 10 of Geology 100 lecture. And in our rock series that we've been talking about for the past few weeks, we are on our last topic, metamorphic rocks. And so we've already talked about minerals, we talked about igneous rocks, and we've talked about sedimentary rocks. Now, unlike the other rock types, metamorphic rocks are way different. They undergo a process of metamorphism, which is a solid state change due to the introduction of changing temperatures and pressures. It's completely different from the other rock types. So for igneous rocks, where it started off as a solid rock that was then melted and then cooled and solidified and recrystallized into a solid rock, either in Earth's interior, so at depth, or on Earth's surface. And then you have sedimentary rocks, which are created as a result of the crushing and eroding and abrading and movement of pre-existing rock that is then transported and deposited and then slowly lithified into solid rock, thus creating sedimentary rocks. Metamorphism doesn't require any kind of melting of pre-existing rock, nor the crushing up and creating of sediments, which then lithify into solid rock. Metamorphism occurs when you take a solid rock and you place it under changing temperatures and pressure for long periods of time. Thus, you get a change in the texture and thus the mineralogy in order to create metamorphic rocks. Now, that may sound confusing, and we'll talk about the specificities and how exactly this occurs. We've talked about igneous rock, which are obviously cooled from some kind of melt or magma, and they can either cool at depth or they can cool on Earth's surface. In either case, you produce either an extrusive igneous rock or an intrusive igneous rock. We know that this igneous rock that is exposed at Earth's surface can thus undergo a bunch of different natural processes. Those can include weathering and erosion, and thus we begin to break up this solid rock, and then those sediments get transported and deposited. Then they can get buried and compacted and then cemented in order to create a sedimentary rock. Now, in both cases of our intrusive igneous rock or our sedimentary rock, what can happen to it? Both of those rock types can obviously get uplifted and thus being in place and subjected to this part of our rock cycle, or they can get buried further and remain at depth. When that occurs during this deeper burial and they remain there for long periods of time, they get subjected to varying temperatures and pressures. Thus, we can begin the process of metamorphism, which is the solid state change of pre-existing rock due to the introduction of heat and pressure. So what exactly happens? That beginning rock, that solid rock that then gets subjected to temperatures and pressures, changes as a result of heat and pressure. That beginning rock, we call that the parent rock or the protolith. Now, that protolith can either be a sedimentary rock or an igneous rock. And in some cases, it can also be metamorphic rock that will then undergo another process of metamorphism. What happens regardless of that protolith, the parent rock, when it's subjected to heat and pressure, it can change the texture and thus the mineralogy of the original material. So on the screen here, on the bottom left-hand corner of this image, you can see what is a limestone, a very fossil-heavy limestone. We call this a fossiliferous limestone. Now, this is a sedimentary rock. When it gets buried further at depth, it's subjected to an intense amount of overlying pressure. For the most part, it's uniform in all directions, but then it could be subjected to intense amount of heat. Not to the point where it will melt down and thus turn into some kind of magmatic body, but to the point where all those bonds in that solid rock begin to slightly break and recombine with other atoms nearby. This recombining of those atoms, we call that essentially a recrystallization, where you don't have any kind of chemical change. You're not taking out any atoms or adding any kind of atoms to recreate the chemistry of that rock. What happens is that internal chemistry, that atomic structure of that original rock gets changed around. And thus it produces a different kind of texture. And in some cases, it can produce a different kind of mineralogy. So its beginning protolith, this fossiliferous limestone, can thus become its metamorphic counterpart. And this rock, we call it a marble. So marble is essentially metamorphosed limestone. So marble's protolith is a fossiliferous limestone. On the right-hand side of the screen here, you can see on the left-hand side, which are different protoliths, so that beginning rock. And what is then produced on the right-hand side is its metamorphic counterpart. So when all of these different kinds of cross-sections snapshot at these protolith rock undergo metamorphism, which means that they're subjected to some kind of changes of temperature and pressure, they begin to metamorphose, which means the mineralogy inside recrystallizes in its basic sense. Again, we're not melting anything or destroying anything. It's just those atoms begin to recombine and those bonding change within that solid rock.